In this lesson, we're going to look at extrema. By the end of the lesson, you should be able to answer, how do you determine the intervals on which a function is increasing or decreasing? And then, how do you identify local, also known as relative, and absolute extrema? So when I look at a function, there are intervals on which it's increasing, where it's constant, or where it's decreasing. And when I talk about these intervals, I'm looking at the x values for which the y value is either increasing, constant, or decreasing. So let's examine this polynomial function over here to talk about where is it increasing or decreasing. So as I move from left to right on my x values, I'm increasing until I hit this point right here. My function then begins to drop until I hit this point, and my y values once again begin to increase. So the x interval on where it's increasing at first is, it's increasing until I hit this x value of 2. So my interval goes from negative infinity all the way to positive 2. This would be the ordered pair to 0 right there. And then it decreases, and it begins increasing again once I reach down here. At this point, this would be for negative 4. So, union, it increases from 4 to positive infinity. Now, you may have noticed that I used a parentheses in interval notation for both 2 and 4. The infinity should be no surprise. But we don't talk about a point. A function is not increasing or decreasing at a single point. So we always use parentheses when we talk about is it increasing or decreasing. So when I'm looking at the interval for where is it decreasing, I'm looking where does, as x increase, where does y decrease? So that appears to be in this region here, in this interval. So that is the x values between 2 and 4. And again, just notice that these are intervals of the domain. And finally, if we look at where's this function constant, this particular one is not. We're really looking at as x values increase, your y values remain the same. Let's use the same polynomial function to talk about extrema. So extrema are critical points at which a function changes its increasing or decreasing behavior. We have local or relative maximum and minimums, and then we have absolute maximum and minimums. So these local max and min are your peaks and your valleys, okay, where it changes direction, or you could say it's the highest point on a given interval. So it doesn't go higher than this y value right here within this interval, and here's a relative or a local minimum down here. It's not the absolute highest or lowest that this function goes. It goes lower way down here. This is not the highest this function goes. It gets higher up here, but it is a local or a relative max. Down here is my local min. So my local max occurs at y equals 0 at x equals 2. So since when we're talking the max, we're really talking about the y. Often we'll mention the y first. Sometimes you'll see it just written as an ordered pair. The local minimum occurs at y equals negative 4 is the lowest it goes in that particular interval at x equals 4. Now, as far as an absolute max or a min, it is the absolute highest or lowest point a function reaches. Since the end behavior of this function is going up towards positive infinity and negative infinity on the left, there is no absolute max or min, but there would be graphs if your end behavior looked like this. This would have an absolute minimum, whereas if your curve is like this, where the end behavior is going up towards positive and negative infinity, this has none. It has no absolute max or min. And then, if you have something that's like this, where your end behavior both goes down on either side, this would have an absolute max in this scenario. In this problem, we're asked to determine the intervals on which the interval is increasing, decreasing, or constant. So I usually take a second and I label these critical points here. So negative 4, negative 1, it just kind of helps me state my interval. This looks like 2, negative 4. And then over here, that looks to me like it's 5, 2. Okay, so let's see, where is this increasing? It seems to be increasing on 2 intervals, on this one and this one here that I just highlighted in yellow. So let's talk about that. So from, I would say, negative infinity to -4, because I'm concerned with the domain values, it's increasing. Union from 2 to 5, it increases again. Okay, so where's it decreasing? It seems to be decreasing on this interval I highlighted in red, which would be from -1 to 2. Again, notice I'm using parentheses because it's neither increasing nor decreasing at a particular point. And then where is it constant? It seems to be constant on this last portion of my graph, which would be on the x interval from 5 to infinity.